Welcome to another lesson of Math 0420, Introductory Algebra. In this section, we will be discussing 1.8 Exponents and Order of Operations. In this video, we will discuss evaluating exponential expressions, simplifying algebraic expressions with exponents, using the Order of Operations agreement, evaluating mathematical models, and evaluating exponential expressions. Let's get started with an example. Example 1. We want to evaluate. For our first part of this example, we want to consider 6 squared. Well, in this case, the number 6 is what we call the base. The number 2 in superscript is called the exponent. 6 squared is the same as 6 times 6. That's what the exponent indicates, that we have 2 factors of 6. So that's equal to 36. Okay? What happens if we have negative 4 raised to the 3 power? Well, that means that we have 3 factors of negative 4. That means we have an odd number of negative factors, so our final answer will also be negative. So we have 4 times 4 times 4, and that is 4 times 4 is 16, times 4 is 64. What if we had negative 1 to the 4th power? Well, in this case, we have an even number of negative factors. 1 times 1 is 1, times 1 is 1, times 1 is 1. Again, this one will be positive, so we get a positive 1 as our final answer. Let's look at a similar problem where we have negative 1 just raised to the 4th. Notice we don't have the parentheses this time. Well, our order of operations, as we'll discuss further as we go on, deals with exponents before multiplication. So we're actually considering 1 to the 4th first. Well, 1 to the 4th power is 1 times 1 times 1 times 1, which is just 1. But then we multiply it by negative 1, so our final answer is negative 1. Okay, that sort of gives us an idea of a concrete example using exponents. Let's now talk about a definition of what an exponential expression is and what this means in general. Definition. If b is a real number and n is a natural number, then we have that b raised to the n power. Again, what is our b? Our b is our base. And our n is our exponent. Well, b to the n is equal to b times b times b times some more times b. How many b's do we have? Well, we have n factors of b. B appears as a factor n times. So this entire expression is read as b to the nth power, and the expression b to the n is called an exponential expression. Also, we have that base b raised to the 1 power is just b. Okay, let's do another example. Example 2. We want to simplify if possible. So we start in part A with 16x squared plus 5x squared. Well, how do we combine those? We can combine like terms by just adding the coefficients 16 plus 5, because our x squared is the variable to the same power. So that's 21x squared. Let's try another. What if we had 7x cubed plus x cubed? Well, again, these are the same type of animal. X cubed and x cubed can be added together. So our coefficient here in front of x cubed is 1. So we have 7 plus 1, which is 8x cubed. Okay, let's do one more. What if I have 10x squared plus 8x cubed? Well, notice just by reading those that I have x squared and x cubed. We can't add those together, so they cannot be simplified further. So cannot be simplified. Okay, let's now talk about order of operations. Order of operations. You've probably heard in your mathematical lives the mnemonic PEMDAS to refer to the order of operations. And while that is helpful in remembering the order of operations, we need to be careful, particularly when we consider multiplication and division, as well as addition and subtraction. So the first thing that you'll do is P, and that is to perform all operations within grouping symbols. That's parentheses, brackets, etc. Then you want to deal with the E, or the exponential expression. So we evaluate all exponential expressions. Then M and D, or multiplication and division, go together. So we do all multiplications and division and divisions in the order in which they appear from left to right. And then finally, we do all of the additions and subtractions together. So we do all additions and subtractions in the order in which they appear from left to right. So again, we do all of our grouping symbols, so parentheses, exponents, multiplication and division, and addition and subtraction in those orders. Okay, in that order, excuse me. So let's move on to an example of order of operations. Example 3. we want to simplify. And we want to simplify 20 plus 4 times 3 minus 17. Okay, so for the first thing that we need to ask is, do we have any grouping symbols? Any parentheses, any brackets? Well, the answer is no. Then we need to ask, do we have any exponents? Well, it doesn't look like we have any exponents in this expression. So we can then move on to do multiplication and division. Well, the three operations we have in this particular example, we have an addition, a multiplication, and a subtraction. So we only have the one multiplication here, which is 4 times 3. So we can simplify that to be 20 plus 4 times 3, which is 12, minus 17. Okay, so 20 plus 12, we now do the additions and subtractions together from left to right. 20 plus 12 is 32, and then 32 minus 17 gives us a final answer of 15. So that's our first example using order of operations. Now let's do a little more complicated example. Example 4. Same instructions, we want to simplify. And this time we have 7 squared minus 48 divided by 4 squared times 5 minus 2. So again, first question we need to ask, are there any grouping symbols? Do we have any parentheses or brackets? The answer in this case is no. Then we need to ask if we have any exponential expressions. We have 2. We have 7 squared and 4 squared. So we can deal with those. 7 squared is 49. Just copy down everything else. 4 squared is 16 times 5 minus 2. Okay, now we're done with exponentials. We now need to deal with multiplications and divisions from left to right. Okay, so we have 48 divided by 16 and then times 5. Well, 48 divided by 16, negative 48 that is. Negative 48 divided by 16 is negative 3 times 5 minus 2. Now we can deal with that 3 times 5. That's 49. So negative 3 times 5 is negative 15 minus 2. 49 minus 15 is 34. That's minus 2. 34 minus 2 is 32. Okay. That's using the order of operations there. Let's do another example. Okay, example 5. Instructions are the same to simplify. Part A. We have in parentheses 3 times 2 quantity squared. So again, we'll go through the same order of operations. Do we have any grouping symbols? The answer is yes. So we perform the operations within those grouping symbols first using the same order of operations. We have 3 times 2 inside, so that gives us 6. And then that quantity is squared. We know that 6 squared is 36. Okay, let's do one more. This time we have 3 times 2 squared. Again, this is almost identical except for not having those grouping symbols. So will we get the same answer? Well, the answer you'll see is pretty clear that it's a no. So we do exponents before we do any other operation since there are no grouping symbols. So we do 2 squared, which is 4. And so now we only have one operation left, so we do that one, which is multiplication. 3 times 4 is 12. Well, 12 is not 36, so grouping symbols make a difference when it comes to using the order of operations. Let's do another example. Okay, example 6. Instructions are to simplify. And this problem involves everyone's favorite part of arithmetic, and that's dealing with fractions. So we have negative 1/2 quantity squared minus, in parentheses, 7 over 10 minus 8 over 15 quantity squared times a negative 18. Okay, a lot going on here. You might feel sort of stumped when you first take a look at this, But if you remember back to our order of operations, the process is the same, regardless of how nasty the problem looks initially. So the first question you need to ask yourself is, are there any grouping symbols? And the answer is yes. We have grouping symbols here, here, and here. Okay? Inside those grouping symbols, there's no operation here in the first part. There is in the second, and there's not in the third. So the only one we need to focus on to start with is 7/10 minus 8/15. Now, those don't have the same denominator. 10 and 15 are not the same. So we can't just subtract 7 from 8 and then 10 from 15. That won't work. What we need to do is find a common denominator. So the common denominator between 10 and 15, we look at the multiples of 10 and the multiples of 15. Well, the multiples of 10 are 10, 20, 30, 40, 50. The multiples of 15 are 15, 30, 45, 60, 75, and so on. So the first common denominator that we'll find is 30. So you can go through this and write the steps out. I'm just going to go ahead and write through this one. So we'll keep -1/2 quantity squared the same, minus, and then in parentheses, to get from 10 to 30, I multiply the denominator by 3. So I'll multiply the original numerator 7 by 3. So I get 21 over 30. To get from 15, our denominator in the second fraction, to 30, I multiply that denominator by 2. So I'll have to multiply the numerator 8 by 2 to get 16 over 30 squared, and then I just copy the -18. Now I can perform that subtraction inside the parentheses. So again, copying everything else down. And I get 21 over 30 minus 16 over 30. Because they now do have the same denominator, I can just subtract off the numerator. So 21 minus 16 is 5 over 30. Quantity squared times -18. Now you'll notice that this 5 over 30 can be simplified. Both 5 and 30 have a common factor of 5, so we can divide that out. Again, copying the other parts as they were. 5 divided by 5 is 1. 30 divided by 5 is 6. That'll make our squaring a little bit easier. Okay, now we have two different grouping symbols with exponents on it. So first we take -1/2 and square it. So you square the numerator, square the denominator. -1/2 squared, -1/2 times -1/2 is 1 over 4. And 1/6 times 1/6 is 1/6 squared, which is 1 over 36 times the -18. Okay, still doing our order of operations. We now have multiplication of the -1 over 36 times -18. So that is 1 over 4 plus 18 over 36. And 18 and 36 have a common factor of 18. Can divide both of those by 18 to get 1 over 4 plus 1 over 2. Those have different denominators, but we should be able to see that 1/2 is equal to 2/4. You can do that. You can write that out if you need to. 1/4 plus 2/4 is 3/4, which is our final answer. Okay, so that was a little more difficult. Dealing with fractions can take time because we have to find common denominators when we add and subtract fractions with different denominators. But if you step through it methodically, using the order of operations, you can solve these problems fairly easily. Okay, let's try another example. Example 7. We want to simplify. In this example, we have 4 times the quantity 3 times 6 minus 11 plus 5. So this is the first example we've had where we have a grouping a set of grouping symbols inside another set of grouping symbols. So whenever we have this happen, we have to work from the innermost set of grouping symbols, that's this inside set of parentheses, and then we'll work our way out and then finally deal with the very outside. Okay, so dealing with the inside, I'll copy everything else down. 6 minus 11 is the first operation, which is -5. And now all we have left are the brackets because there are no operations inside the inside set of parentheses. So we have 3 times -5. We do multiplication and division before addition. So 3 times -5 is -15. Rewrite that. Plus 5. Now the only operation we have inside grouping symbols is -15 plus 5, which is -10. And all we have left now, we have no operations inside the grouping symbols, so we can now do the multiplication. 4 times -10, which leaves us with a final answer of -40. Okay, let's sort of mix it all together and do one that has multiple grouping symbols, operations with exponents. Let's do a little more complicated example. Okay, example 8. Same instructions, still simplifying. This time we have 25 divided by 5 plus 3 times the quantity 4 plus 2 times the quantity 7 minus 9 quantity cubed. Okay, so again, order of operations, we're going to work from our innermost set of grouping symbols. In this case, it's parentheses. We're going to do the 7 minus 9 first. So we'll copy everything else down. And 7 minus 9 gives us -2. We keep that exponent of +3. So now inside the brackets we have that exponent, -2 to the third. So we'll do that next. -2 to the third is -2 times -2 times -2, which gives us a -8 because we have an odd number of negative factors. So we have 4 plus 2 times -8. Okay, still working inside those brackets. We have a multiplication, so that will come before the addition. Still copying everything else. And 2 times a -8 gives us a -16. We have one more operation inside grouping symbols, and that's 4 minus 16. So still copying everything else down just as it was. Inside the brackets, 4 minus 16 gives us a -12. Now working outside of the grouping symbols, we can now do multiplication and division from left to right. So 25 divided by 5 is 5, plus 3 times a -12, so it's actually a minus 36. And 5 minus 36 is -31, which is our final answer. Okay, so we've dealt with some pretty complicated examples of doing order of operations. Well, what happens if we have a numerator with order of operations to go through and a denominator with order of operations? How do we handle a fraction with algebraic expressions in numerator, or with expressions, not algebraic expressions, but expressions in the numerator and denominator? Okay, example 9. In example 9, we are dealing with 5 times 4 minus 9 plus 10 times 3, all divided by 2 cubed minus 1. Okay, now we can deal with the numerator or denominator first. I'll begin with simplifying the numerator first. So we work inside grouping symbols. 5 times 4 minus 9 gives us a -5. Plus 10 times 3. So we're done with the grouping symbols in the numerator. Just copy the bottom down, 2 to the third minus 1. Now from left to right, we can do multiplication and division. We only have multiplication in this case. 5 times negative 5 is negative 25, plus 10 times 3, which is 30, divided by, we'll keep the bottom the same, 2 to the third minus 1. Negative 25 plus 30 gives us a positive 5 over 2 to the third minus 1. Now dealing with the denominator, 2 to the third is the first thing we do because it's an exponent, exponential expression. So we get 5 over 2 to the third, which is 8 minus 1. Now we just have subtraction. So we have 5 over 8 minus 1, which is 7. So our final answer here is 5 over 7. We can't reduce that any further, so that is our final answer. Okay, now let's try an example where we evaluate an algebraic expression for a given value of a variable. Example 10. For example 10, we want to evaluate the algebraic expression negative x squared minus 4x for x equals negative 5. So in this case, we want to plug in our value for x, which is negative 5, everywhere we see an x. Okay, so we'll plug in negative of negative 5 squared. Again, x is negative 5, so we're squaring that, minus 4 times negative 5, which is negative 4x. Okay, so we use the order of operations. We have this exponential expression, negative 5 squared. Negative 5 squared is 25 because we have an even number of negative factors. So we have the negative of 25. And then we can copy the rest down, negative 4 times negative 5. So negative of 25 is just negative 1 times 25, so negative 25. And then negative 4 times negative 5, even number of negative factors, so it's positive. Negative 4 times negative 5 gives us positive 20. So negative 25 plus 20 is a negative 5. So when we plug in x equals negative 5 into our algebraic expression, negative x squared minus 4x, and using the order of operations, we find that the result of our evaluation is negative 5. Let's do one more example where we're dealing with an algebraic expression. This time, instead of evaluating, we're going to simplify an algebraic expression using the order of operations. Example 11. This time we want to simplify. And our algebraic expression is 14x squared plus 5 minus the quantity 7 times the quantity x squared minus 2 plus 4 in brackets. Okay, so we work from the innermost set of grouping symbols, so inside the brackets, and then inside the parentheses is our innermost. Well, x squared minus 2, there's not really any simplification we can do there, but we can distribute our 7 inside here. So we'll do that first. So 14x squared plus 5 minus 7 times x squared gives us 7x squared. 7 times negative 2 gives us minus 14 plus 4. Okay, we can now combine the like terms inside the brackets. So we get 14x squared plus 5 minus 7x squared. Negative 14 plus 4 gives us a negative 10. Now at this point, it's important for us to see that we have a negative right here, which is associated with this entire expression. We want to subtract off this entire thing, so we can distribute that negative to the 7x squared and to the negative 10, and when we do that, we'll change the symbols, or the signs. So So 14x squared plus 5, still following order of operations because we're doing multiplication now that we're done with the grouping symbols. So we'll have -1 times x squared, which is 7x squared, and -1 times the -10, which is a +10. Okay, now that we've dealt with all of the multiplications and divisions, we can combine like terms. So we have a 14x squared minus 7x squared. 14 minus 7 is 7x squared. And then we have a +5 and a +10. So 5 plus 10 is 15. So our fully simplified expression is 7x squared plus 15. Our last example of this section is example 12, which comes directly from your book as checkpoint 13 in this section. We want to evaluate a mathematical model, and that is that a company that manufactures running shoes has weekly fixed costs of $300,000, and it costs $30 to manufacture each pair of running shoes. The average cost per pair of running shoes, which is C bar, for the company to manufacture X pairs per week is modeled by the formula C bar is equal to 30 times X, which is the number of shoes, plus 300,000 divided by the number of shoes. So our job in this case is to find the average cost per pair of running shoes for the company to manufacture. In part A, we'll look at 1,000 pairs per week. In part B, we'll look at 10,000 pairs per week. And in part C, 100,000 pairs per week. So we're looking for various values of C bar when X has different values. So in part A, X is equal to what? Well, it's equal to 1,000 pairs, so 1,000. In part B, X is equal to 10,000. And in part C, X is equal to 100,000. Okay, so let's go ahead and start with part A. We want to substitute into the formula that we have right here, that model. We want to substitute in X equals 1,000 in both places. Okay, so C bar equals 30 times 1,000 plus 300,000 divided by 1,000. Okay, well, 30 times 1,000 is 30,000 plus 300,000 divided by 1,000. Well, that's 330,000 divided by 1,000. And 330,000 divided by 1,000 gives us 330. So in part A, the average cost per pair of running shoe when the company makes 1,000 pairs a week, 1,000 pairs a week given the fixed cost and this model is the average cost of $330 per pair. Okay, let's see what happens if they scale their production to 10,000. So in part B, remember X is equal to 10,000. So C bar is equal to 30 times 10,000 plus 300,000, that fixed cost, divided by the number of pairs produced per week, which is 10,000. So 30 times 10,000 is 300,000 plus 300,000, all divided by 10,000. So our numerator is 300,000 plus 300,000, which is 600,000, divided by 1,000. And 600,000 divided by 10,000, oh, not 1,000, 10,000. 600,000 divided by 10,000 is 60. So the average cost per pair of shoes, if they produce 10,000 pairs per week, is $60. Okay, what if they scale up their production to 100,000 pairs per week? Okay, well, that's part C. And so C bar would be equal to 30 times 100,000 plus 300,000 over 100,000. Well, 30 times 100,000 is 3 million. I'll use commas here so we can see it. Plus 300,000 all over 100,000. Okay, 3 million plus 300,000 is 3,300,000 divided by 100,000. And if you enter that into your calculator, 3,300,000 divided by 100,000 gives us an average cost per pair of $33. So you can see, using this model, the more shoes the company produces, the less the cost per pair is. And so where we started with only producing 1,000 pairs of shoes, we ended up with an average cost of $330. By the time we get up to 100,000 pairs per week, the cost is down to $33. That is the end of section 1.8, Exponents and Order of Operations. If you have any questions on your homework, please let me know. Good luck on that, and I will see you in the next one.